Yeah, thank you, Grandel. So this work has been done with my students. With my students, Chidambar and Jashan, and today I will be talking about intelligent multi-agent content steering for Dash. Okay, so as you know all that we bring the content near to the user thanks to the CDN, and that help us to improve the quality of experience, minimize the latency, as well as increase the scalability. However, using a single CDN has a lot of issues. For example, if you have a service outage or CDN overload, then that will be very determinant for the quality of experience, right? Therefore, what's the solution here is the multi-CDN architecture. So for the multi-CDN, in a nutshell, that you have a couple of CDNs, it's from multiple vendors, right? And then you leverage the power of these CDNs. But for sure, you need like a logic or a policy to switch between these CDNs in real time. So this figure shows the end-to-end pipeline for multi-CDN architectures. So as you can see, we have the content streaming, and then you have the clients, you have the CDNs, and then you have the origin, and then you have aggregate analytics. And today, Grandel already speak about the interaction between these different entities of the system. So here, the main, I would say, focus of this presentation on Dash, not HLS. So in the literature, there has been a couple of CDN switching techniques. For example, we have a DNS-based where you actually use DNS to forward the requests to the CDN. However, it has an issue which is like high switching delays. The second one is manifest rewriting. In real time, you write the manifest. However, you might have a problem while rewriting, and that will lead to a disaster maybe for a quality of experience. We have also server-side CDN switching, and that has some delays. If you don't switch on time, that also might lead to a low quality of experience. We have also client-side CDN switching. However, you need to integrate that on your player, which means it might harm the scalability. Therefore, what's the solution is the content steering. If you look to the content steering, we have multiple, I would say, approach to switch the CDNs. The first one is static, where you can use like a random, you can use round robin, you can use list connected, or you can use deterministic, where you assign weights, right, to forward the request to the CDN as per those weights. As well as we have dynamic heuristics that's based on RTT, where you can select the CDN with the lowest RTT or with the high throughputs, right? However, those heuristics or dynamic heuristics might fail in diverse network conditions. You have 3G, 4G, you have satellite network, right? So then what's the solution? The solution is IMAC, or we called it Streamwise because it's a published paper this year at MMSIS. What's Streamwise? Streamwise is actually an online multi-agent learning-based DRL solution for adaptive real-time CDN selection in content string. So here you can see the, I would say, the DRL architecture of Streamwise. It's based on actor critic with PPO for policy selection. So it takes as an input bitrate lists, rebuffering lists, and delay lists. Those lists are actually the values from the clients, where we convey this information using CMCD version 2, and today we'll discuss that. And so that's the input in our DRL. So for the reward function, we consider this reward function. You might ask why. So we did a lot of experiment on multiple reward functions, and this is the best that we can achieve or converge to what we were looking for. So which actually combine, it's a linear combination of selected bitrate, rebuffering durations, and the delay. And this actually fine-tuned values. For the deployments, so here actually, if you look to the Streamwise, since it's multi-agent, so it follows the structure of structural training and the distributed execution, which means in the execution, we actually kind of create a model to a specific client or specific session, which means it can adapt to the user demand as well as to the network conditions. So this actually what have been shown here. Of course, we need to modify the MPD where we added actually the locations of the CDN. Here in our experiment, we used actually 4 CDNs. For training the model, we use actually 2 data sets. One is provided by Microsoft Grand Challenge MMSys, and the second one is from Pensive, which is the first DRL-based ABR that was presented in SIGCOMM conference. So this here is like it's a detailed setup where we have actually 3 Dockers. So in Docker 3 is like we have 4 CDNs. Docker 2 is the content steering with Streamwise to select the CDN as well as with TC to shape the bandwidth. And then we use actually Docker 1, which is the Go Dash players based on Go. Why we use Go actually for scalability, where we can scale our setup to support 100 clients, right? And here, as you can see, which is a bit different, we have actually a TC for each CDN to actually mimic real world scenarios, as well as we have a TC for the client, right, to mimic actually last mile networks. And these are actually the values or the ranges of the traces that we have used for like 3G, 5G, Twitter, Cascade, as well as the enter variation duration by switching these values. And also we created the specific trace which mimic 4G and 5G to actually experiment with the high volatility issues. If you are running on 5G, if you go like inside, you maybe your phone switch to 4G, and that will be very crucial for the quality of experience, right? And this actually, the Streamwise, we compared against all of these techniques, static heuristics and dynamic heuristics. This is the bitrate ladder that we have used actually, and the count is moment of intensity. It's 4K, the highest bitrate, and we tested actually our solution in 2 scenarios. One is VOD and the second one is low latency, and these are all the parameters that we have used. For the ABRs, we use buffer-based BBA, Pensive DRL, and Marina also is a DRL. For the scenarios is multi-server single client, where we have only client and multi-servers, or 4 CDNs. And for the second scenario, where we have multi-servers, multi-client, we have these 2 scenarios. So we have more experiments, but here I just put like the few of them, okay? As you can see, the Streamwise is the blue one. As you can see, so the first or the right-hand side, we have the average rebuffering durations versus VMAF. So the best one will be in the corner, top corner. As you can see, Streamwise in blue achieves a great VMAF with less rebuffering, and it's near to the optimal. The optimal is actually offline based on a brute force technique. Similarly here, the bitrate is good. So in a nutshell, we achieved 67% reduction in rebuffering and 20% improvement in VMAF on average compared to those techniques. For the bitrate as well, like we get around 155% improvement in bitrate with 20% more UHD segments compared to the second competitor. So yeah, this actually experiment for low latency, yeah, and the results are average over 3 ABRs, 2 runs, and 3 traces. Okay, so the second one is the same, but for video on demand, we achieve similar results, where Streamwise always the best, as you can see, in terms of VMAF, rebuffering, as well as the bit rates. Yeah. This shows like how many times we switches between CDN in the case of LLL as well as video on demand, which means the CDN frequency between CDN 1, CDN 2, CDN 3, and CDN 4. So here actually the average result shows that Streamwise switched the CDN 18% in case of LLL and 21% in case of video on demand. And this results is for multi-server, multi-clients. Streamwise always the best. It achieves the best results, as you can see, in terms of rebuffering and VMAF, as well as in terms of what we call the bit rates. So as you can see, in the right-hand side is low latency scenario, and the left-hand side is the video on demand. And the Streamwise, the one in the blue. Okay, and yeah, so we integrated Streamwise with in Dash.js, and actually we took the Dash.js implementation and then we integrate our solution. So thanks for Dash.js people for providing that sample. And one thing also that I want to mention here, that we implement also a tiny RTT tracking, because Grundle today discussed the idea of sacrificing some client. For us, we use the same as VTA, where we do a probing to track whether the CDNs are healthy or not. And then we did it actually periodically from the client side. You can actually see the video demo. We have also the online demo where you can enjoy the Streamwise CDN switching. The code will be coming soon. The full paper is published in MMCs this year, and it will be available soon as well in the main track. And one of my students, he will go there and present it. So this is a final note. Can we have a robust CDN switching strategy in multi-CDN deployment? Yes, of course, Streamwise. What's the performance? So it achieves like a great quality of experience. And what's about the CDN switching frequency? As I mentioned, is just 20% of time to respond to the changing network condition. In fact, we implemented multiple policies where you can switch based when you see like a variation in RTTs or variation in QE, you can actually trigger the Streamwise again to select the best CDN, or the client will ask the Streamwise to get the best CDN, right? That's all. So thank you.
Questions? Hi.
Yeah.
A clarification question. What is the strategy to determine when to switch CDN? Is it when all the representations in a given CDN are failing, or because you mentioned probing, you have some hints that it will fail, so you're failing beforehand? Maybe a follow-up is how in terms of buffer depletion, how far do you have to go to make the decision? Like, are you switching very early or very late?
Okay, that's a good question. Actually, we have multiple policies to do so, and we left it for the implementer. The first one, we can use the TTL, for example, right? That's one thing. The second thing, we can use the RTTs, because we are actually sending this information from the clients to the content steering. So we analyze the variations in the RTT, right? And if we see a big deviation, then we trigger the Streamwise again to suggest the best CDN, right? The third thing is the QE variations as well, based on the STD. So we defined some thresholds, right, that allows us to, I would say, trigger Streamwise again and again periodically, but it's up to the implementer. We have a bunch of policies. You need just to select it at the beginning, which policy you want to use, and then all the clients will enjoy the best quality of experience. Yeah.
Hi, thanks. That was very interesting. I think you mentioned that you're making you're evaluating the steering decision roughly every segment duration.
Now, yes, for this result.
For the results you get.
Yes.
Does that mean the TTL in your steering server response was equal to or less than your segment duration?
Actually, it was actually less, because we experienced it based on the traces that we have big RTTs, because we are introducing like delay as well as packet loss there on those. So therefore, we use actually sub-second.
Sub-second.
Yes.
So if you want to scale this up to the real world, where you got hundreds of thousands of players, is the proposal that they would all make sub-second requests to a centralized content steering server? Okay,
so basically this is just for our setup, but as I said, we have multiple strategies that we can allow the implementer to do, like when you have let's say a variation in the RTTs, but of course it will not scalable. It will not be scalable if you use like sub-second, if you have millions of users, because that's too much from like, even like the inference is like in few milliseconds. However, you will have a specific model for each of the clients, and that also will be costly in terms of the content steering itself. So therefore, we have to have that balance, right? And also that depends on the use case, whether it's low latency use case or it's a video on demand use case. So yeah.
I think for further study, it'd be very interesting to look at the sensitivity of the TTL in your steering server response to the benefits that you're getting there. So you can, a deployer can make a trade-off. If I go to 5 seconds, how much less rebuffering am I going to avoid?
Yeah, thanks for the suggestions. Yeah.
Any other question? Yeah, 20% of switches frequency. So it means that every 5 segments we switch, right?
Yeah, but the thing that we trigger the streamwise every segment, sometimes like the streamwise not stack, but select the same CDN for some period of time because it's the best performing one.
Yeah, I think in the next presentation, switching CDN is seen as a penalty in terms of QoE. So it means that you will get some penalty for this, according to Yuri's equation. And if we want to consider business-wise system here, how would you do this?
That will be in the second paper that we are working on, and it will be out soon, where we consider the businesses plus the cost and the energy as like a holistic reward function. And that's something, it will be, we are cooking it and it will be out soon.
Good.
Yeah.
Thank you.
Okay.
Thank you.
Okay, thank you.